ChatGPT is powerful, but it doesn't know your data, your knowledge base, your documentation, your frequently asked questions. What if you could build a chatbot trained on your own data? In this video, we are building a custom GPT chatbot using Apple support frequently asked dataset. Let's build it. Before we move ahead, let me quickly show you a high-level architecture of the chatbot we are going to build. Here is how it works. First, we load our custom data. In this case, Apple customer support questions. Second, we convert the question and answers into embeddings like a numerical representation that capture meaning. Third, when a user asks a question, we find the most relevant frequently asked questions using the similarity search. Finally, we send those frequently asked questions to the GPT with the user questions and it generates natural response. This diagram represents the overall flow of how our custom chatbot will work. Don't worry if everything isn't clear yet. We will go through each step in detail as we build it. By the way, I created this diagram using Mermaid. If you want to learn more about Mermaid diagram, I have made a separate playlist on it. You can find the link in the description. Alright, now let's move to the VS Code. First, we will start by creating a notebook. You can either click here to create a new Jupyter notebook, or you can also create one from here. Name this notebook like custom chatbot and hit enter. Next, we need to install a few packages for our development. But before that, we need to connect the notebook to a Python kernel. Here we have couple of options. We can either use a local Python environment or connect to a Google Colab directly from VS Code. For this tutorial, I will be using a local environment, but you can also use the Colab in VS Code if you prefer. You can check this video for more details. Now let's install the required packages. We will need a few libraries like pandas, numpy, scikit-learn, openai. We also need python.env to manage the environment variable securely. Execute this cell and it's done. For this project, we will be using GPT model, and to access any GPT model, we need an API key. So first, we need to generate that key. There are the two ways to use the GPT model. The first option is the paid version, where you use the model directly from the OpenAI platform. You can go to the OpenAI dashboard, navigate to the API key, click create a new secret key, give it a name, and then click create. Your API key will be generated and you can copy it. However, to actually use this API, your account must have some credit available, otherwise the request won't work. As you can see, in my account I don't have any credit right now, so we won't be using this option. Instead, we will use the second option, which is free for development. For that, we will go to the GitHub. Yes, you heard that right. GitHub also provides access to premium LLMs model for free, although with some rate limits, but it's perfect for development and learning. So here I am on my GitHub page. Click on Marketplace, and this is the landing page where you can explore different LLM models. You can browse the models based on different use cases. Just click on models and then open the model catalog. Here you will find a library of different models including GPT-5, GPT-4, GPT-4o, embedding models, and many more. For this tutorial, we will be using GPT-4o-mini. Click on this model. You can see here that it offers a free rate limit tier, which is great for development. This model is a part of Azure OpenAI service. Actually, Microsoft has partnered with GitHub to bring Azure AI model directly to the developer through the GitHub marketplace, which make it easier to experiment with different models. The reason of selecting this GPT-4o-mini is that it's a lightweight yet powerful model. It provides strong intelligence while being very fast and cost efficient, and even outperform GPT 3.5 Turbo in many cases. Now we need to generate API key to use this model. Click on Use this model. This page shows the documentation including usage instructions, pricing, and rate limits. From here, click on Personal Access Token. You can give it a name if you want, or just leave it as default. Then click Generate Token. Click again. And that's it. Your API key is generated. You can now copy it and use it in your project. Alright, now let's go back to the VS Code. First, we will import the packages that we installed earlier. Now, to use the API key, there are two ways. First option is to paste the API key directly into the code as a variable. This is simple and quick, but it's not recommended for production because you might accidentally commit your API key to a repository. The better approach is to store the API key as an environment variable and load it from there. This follows good development and security practices. So let's do the second one. Create a new file called .env. Inside this file, create a variable called openAPI and paste your API key there. Save it this file. Now to use this environment variable in our code, we need to load it first. So we need to import load.env from python.env package. Run this cell. Load the environment variable. Next, we will have to initialize the client for GitHub models. Since GitHub model use Azure Inference Endpoint, we need to provide a different base URL. And finally, we have to pass the API key from our environment variable. Let's run this cell. Great, everything is set up. Now we are ready to start building our chatbot. To start, first we will load our custom dataset. For this project, we are using a small dataset. It contains around 50 Apple support frequently asked questions, including questions and answers about refund policies, store hours, and common troubleshooting steps. This dataset will act as a knowledge base for our chatbot, allowing it to answer the user queries based on this information. To keep things organized, we will use a class and method approach that will handle the different steps of our chatbot pipeline. Create a class called Apple Support Chatbot. Next, initialize the chatbot with frequently asked data. For that, create init method. This is the initialization step. Add a print statement. But for production, you can use a logger as well. Load the data from Excel. This read our custom knowledge base into a pandas data frame. Also verify the data has the right column. This will help in future error if any column is missing. So check question is available in data column, or check answer is also available in the column. If not available, raise the value error that Excel file must have question and answer column. Just to be sure, print the length of the dataset. Also initialize the embedding here, as we will use this to store the embeddings. Let also keep track of conversation history for context. And finally, initialize the class and pass the file path. Let's see what data we have. Here, the init method loads the Excel file using pandas, our custom knowledge base with 50 examples. You can check that it has question and answer columns. And we are ready to go. Simple so far. Now the magic part, embeddings. We convert each frequently asked question into list of numbers that capture its meaning. Similar questions get similar number. This let us find relevant examples when user asks question. And OpenAI text embedding model does this for us. Let's create a method for embedding. Create embeddings. Start with printing initialization step for embedding. Create a combined text of question and answer for better context. Now the question is, why is that? Why we need to combine? The reason is that embedding both question and answer give us a richer semantic meaning. Like for example, if the question is what is the refund period? Answer is like Apple allow us a 14 days of return policy or something like that. If you see, this is more informative than just a question, what is the refund period? To generate the combined text, we need to iterate over the whole data. Combine the question and answer with a separator. And append it inside the combined text. Before embedding, also check the length of the combined text. Now call client OpenAI API to create embedding for all text. Here is what happening. Each text become 1536 numbers representing its meaning. A response client.embedding.create. Pass the model name text embedding 3 small. The reason of selecting this embedding model is that it's fast, cheap and accurate enough for our task. Also pass combined text as input. Extract the embedding vector from the response. Use numpy to make similarity calculation super fast. Actually, each embedding is a list of 1536 floating point number. So here is how embedding work. Embedding capture that money back, refunds and returns all means similar things. So it will score similar value. And finally check the embedding shape. Check the shape of each embedding numbers. Return the generated embeddings. Finally, add this method to the class. Create embedding for our dataset. Let's see few examples of what embedding look like. Now each frequently asked question is represented as number that capture its meaning. When a user asks question, we need to find the most relevant examples. We convert their question into embedding and calculate the cosine similarity with all the questions embeddings and grab the top matches. It's like asking which examples are most similar in meaning. Let's code that logic. Create a method, find relevant, frequently asked questions. Use variable user questions and top k, which decide how many relevant examples to return. As default, set 3. Print initialization of this method. Step 1 is to convert the user questions into the embedding. This uses the same model as earlier. Get the embedding from question response. Now step 2 is to calculate the similarity between user questions and all other examples from our dataset. Actually, we use cosine similarity to measure the angles between vectors, which score between range from -1 to 1. -1 means opposite, whereas 1 means identical. So typically we see a score between 0.03 to 0.09. 0.03 means somewhat related, 0.09 very similar. Iterate over the embeddings. Here we are calculating the cosine similarity between the user questions and the examples. So here the cosine similarity formula is dot product of question embedding and examples embedding divide by the normalization product of question embedding and example embedding. This gives a similarity score of question and one example. We need to iterate for all and append inside the similarities list. Convert into numpy array for easier and faster manipulation. Step 3 is to get the indices of top k most similar examples. Sort it reversely and select the top k. Step 4 is to prepare the result. Select the question, answer and similarity score. Print it, which help in debugging. Return relevant frequently asked questions. Also add this method to the class. Now test the similarity search. Test with the questions like, can I get a refund for my iPhone? A relevant equal chatbot.find relevant FAQs. Pass this test questions. Pass top k3. Print the question, answer and the relevant scores. Here we get that the find relevant method is our search engine. If you see, the math is just one line, but it is quite powerful. It finds semantically similar questions even if they use different words. Now the final step, generating the response. We take the relevant examples, package them as a context and send everything to GPT-4. We tell the GPT, here are the user questions and here are the relevant examples. Give a helpful answer. GPT combine the information and respond naturally. Let's see in the action. Create a chat method. Print initialization of this method. Start with the step 1 to find the 3 most relevant examples from our dataset. Call the find relevant method and pass the user message. This is our retrieval step. Step 2, build the context for relevant example. Format the example nicely so GPT can understand them. For that, iterate over the relevant examples. And lastly, the third step, build the conversation message for GPT. GPT expects a list of messages with a role like system, user, assistant, etc. And each roles have different set of meanings. Like for role system, set behaviors like a hiring instruction for an employee. For role users, it's like customer questions. And for role assistant, it's a GPT previous response for context. So messages like first, define the role as a system. Content. Now in content, define the set of behavior and personality of the chatbot, like you are defining the rules for the chatbot. When role is a system, this is very crucial. This is how we make it a Apple support chatbot. Without this, GPT would like a generic chatbot. With this, GPT know to use only our frequently asked question and be an Apple assistant. Here are the list of the rules that chatbot need to be followed. Like use only the information provided from the frequently asked questions. Be friendly, clear and concise. Always maintain a professional and helpful tone, etc. Define another content for user message. A role, user. Content is the context that earlier passed. And lastly, step 4, call the GPT API. As we are using GPT-4o-mini because it is lightweight and very powerful, create the response openai.chat.completion.create. Set model GPT-4o-mini. Pass the messages. This is our conversation with system plus user message. Set temperature 0.07. It's like balance between creative and focus. Set max token length 500 and presence penalty 0. Don't penalize using same word and also don't penalize with repetition. Extract the response text. Response.choice.message.contain. And finally, add this response to the conversation history for future references. Append with role and content. And also print the GPT response. Return this assistant message. Also add this method to the class. Now chat feature is ready. Let's test our chatbot. Ask with a chatbot, can I return my phone if I opened it? And here it responded. Test again with some other examples. Like how long does it take to get my refund? Here it also returns the response. If you notice the output, you will find that it first finds the most relevant examples using our similarity search and then format them as context for GPT, which return the natural language response to user. This chat method ties everything together. First, it finds the relevant examples using our similarity search. Second, format them as context for GPT. Third, it creates a system message that tells GPT to be an Apple support assistant. Fourth, send everything to the GPT. Fifth, return the natural language response. Note how we define the rules for GPT. Only use the frequently asked questions. Be helpful and admit it doesn't know. This keeps response accurate. Let's create an interactive loop so you can chat with the bot naturally. We will add a simple command line interface where you type the question and bot will respond. This make it feel like a real chatbot conversation. Create a new method, run interactive chat. Initialize the chat header about the Apple support chatbot. Mention about the context user can ask with this chatbot. Also convey how to end the conversation. Create an infinite loop. Get the user input. Create an exit path for this interactive chat. If user pass input like quit, exit, bye or goodbye, we will end the chat. And print a greeting message like thanks for contacting Apple support. Have a great day. Break the loop. Also check if user input is empty. Now here we are using try and accept method to avoid any failure due to some error. Get the chatbot response. For that, pass the user input inside the chat method. Print the response. Handle the error gracefully. Also ask user to rephrase the question. Add this method to the class. Let's again test the chatbot using interactive loop. Call the run interactive chat method. VS Code won't allow user input in the cell. It will ask the user input at top of the screen. Check the return policy with a chatbot. And here it returns the details about the return policy. Again check about troubleshooting issues like what happens if my phone won't turn on. And it returns the troubleshooting steps to resolve the issue. The interactive loop is simple. It takes user input, send it to the chat method, display the response, and continue until the user exits. If any issue occurs, the system catches it and asks the user to refresh the question. This approach keeps the chatbot reliable and easy to use. That's it. We built a custom GPT chatbot that answers questions using our own data. You can apply this to any knowledge base like company frequently asked questions, product documentation, support tickets, anything. Code link is in the description. Like and subscribe for more AI tutorials. Happy coding!